Hi everyone, in this lesson we're looking at transformations of logarithmic functions. And this should look very familiar because earlier in the unit we looked at transformations of exponential functions. And nothing really changes at all when we're talking about transformations other than the actual function itself. Before we were looking at y equals b to the x, which was an exponential function. And in this case, the parent function we're looking at is y equals log of x. All the transformations are going to behave the exact same way. So if we look at moving a function vertically, so we would have a plus or a minus k. So if we have y equals log x and we tack a plus 3 on the end, we're going to move it 3 units up. Minus 6, we're going to move it 6 units down. If we put a value inside the parentheses with x, for example, if we have x minus 2, that's going to move it 2 units to the right. X plus 1 is 1 unit left. And notice that's opposite because it's a minus h and not a plus h inside the parentheses. If we have a value outside the function, it's a vertical stretch or shrink. It's a stretch if the value is greater than 1, like a 6, and it's a shrink if the value is between 0 and 1, such as a half. Now, if it's a horizontal stretch or shrink, we're going to have to think of it as 1 over the value. So if we have 1 over 5, that's going to be a horizontal stretch by 5. If we have a value greater than 1, in this case, a 3, value greater than 1 inside the parentheses in front of x is a horizontal shrink by a third. That's always the trickiest one. The horizontal stretch and shrink are usually the most difficult to process. And remember that you should keep this table handy as a good reference. If we have a value that is negative in front of the function, we're reflecting over the x-axis. And if we have a negative value inside the parentheses, that's going to reflect over the y-axis. So let's look at some examples. Let the graph of g be a reflection in the x-axis, followed by a translation 4 units to the right of the graph for the function log base 2 of x. Write the rule for g. So I would suggest for both 1 and 2, you pause the video and see if you can do these on your own. So we have g of x is our new function. And since we're going to reflect over the x-axis, that means that we are going to put a negative out front. We have log base 2. We're also going to be translating the function 4 units to the right. That means inside the parentheses, we're going to do x minus 4. Minus 4 is 4 units to the right. Plus 4 would be 4 units to the left. And that's it for number 1. Number 2, let the graph of g be a translation 2 units up, followed by a vertical stretch of a factor of 2 for the function log base 1/3 of x. All right, g of x. Now we have a vertical stretch, so that means that the value is going to go out front. It's a stretch by a factor of 2. Our base doesn't change, it's base 1/3. And we're moving the function up 2, so our x is just going to stay by itself. You may want to put parentheses there, you don't have to. But we're going to move the function 2 units up, so plus 2. All right. Same idea with number 3. We're writing a rule for g. So we have a parent function, and then we're going to transform it and rewrite the function as g. So we have a vertical stretch with a factor of 6, followed by a translation of 5 units down. For all of these, I would say just pause the video, try them, and come back when you're ready. So a vertical stretch means we have a value out front, and we're going 5 units down. So that's going to be x by itself and plus 5 outside. Now, you can include the parentheses or you don't have to. I just like to include them as good practice. If you have a translation, though, that's going left or right, you absolutely will need the parentheses. All right, for letter B, reflection in the y-axis, that means the negative is going to go right with the x inside the parentheses, followed by a translation of 9 units to the left. All right, so g of x, our log base 5. We're going to have a negative in front of the x, all right, and we're moving that function to the left 9. Now be very careful, you do need to have the parentheses just the way I have them here with the negative out front, unless you decide you want to distribute the negative, but I think that makes it really confusing. So I would just leave it like this. Letter C, we have g of x again. We're going 3 units left and 2 units up and a reflection in the y-axis. So we have log base 1/2. We're going to have that negative in front because of the reflection in the y-axis. We're going 3 units left, so it's going to be x plus 3, and then 2 units up, so plus 2 on the outside. The last one, we have ln of x, that's log base e of x, written in shorthand, ln of x, 3 units right, 1 unit up, and a horizontal stretch by a factor of 8. Ooh, horizontal stretch by a factor of 8. That means we're going to have the 1/8 fraction in our answer. So we have g of x, ln, the horizontal stretch by a factor of 8, so we're going to have a 1/8 in front. We're moving it 3 units to the right, so that's going to be x minus 3. And then 1 unit up. So outside the parentheses, plus 1. All right. Graphs of log functions. Recall that the domain of the parent log function is 0 to infinity. That means the only x values that are included in the log function are greater than 0. So therefore, the graph of the parent function y equals log of x has a vertical asymptote at x equals 0. An asymptote is a line that a curve approaches as it heads towards infinity. Let's look at the graph. Go to y equals, we'll type in log of x. We'll do zoom 6 for a standard window. Now the graph looks like it ends sort of like right here, but it really doesn't. It just means that this graph is getting closer and closer to the y-axis, which is the line x equals 0. So there's an asymptote on the y-axis, which we could also call the line x equals 0. So it says graph the parent function, then graph the transformation represented by g. All right, so we want to graph the parent function, and I gave you some x values to go with here, 0.1, 1, and 10. So the log of 0.1 is equal to -1. The log of 1 is equal to 0. And the log of 10 is equal to 1. Log base 10 of 10 is equal to 1. And now we're just going to graph those points. Now just be really careful to note where your vertical asymptote is. And we have a vertical asymptote, and I'll do that in blue. We have a vertical asymptote on the y-axis for the parent function at the line x equals 0. So when we draw our graph, we're going to get really, really close to that line, but we're never going to touch it. Right, so that's the graph of the parent function y equals log of x. Now we're going to do the graph where we transform it. Now the transformations include up x plus 3. That means that we're moving this function left 3. And a plus 1 means we're moving it up 1. So let's note that. So if we're moving the whole graph left 3, that means that we're taking all the x values and we're subtracting 3 because we want the whole function to move left 3. So that means we would do 0.1 minus 3, 1 minus 3, and 10 minus 3. All I did was I took these original values for x, and I'm subtracting 3 from each one of those. So I'm going to get negative 2.9, I'm going to get negative 2, and I'm going to get 7. Now, to move the whole function up 1, all the y values have to be increased by 1. So I'm going to take all of my y values, and I'm going to add 1 to them. So I'll have negative 1 plus 1, I'll have 0 plus 1, and I'll have 1 plus 1. And now I'm going to graph those points. Now, since the entire function has gone left 3, it means that my vertical asymptote has also gone left 3. So I have a vertical asymptote at x equals negative 3. So let's sketch that in. And then we'll draw in our graph. And just be careful when you draw the graph to make sure that your line is just getting closer and closer to the asymptote, but not really touching it. All right, that takes care of number 4. Now, it's the same idea for number 5. So again, I would just suggest you pause the video and try this guy on your own. We've already established what the points are for the parent function, so we want to fill that in. We've got negative 1, 0, and 1. And we're going to sketch that graph first, and then we'll examine what's happening with the g function. Now for the g function, I have a negative and I have a 2, both out front. So that negative is going to mean that I am going to reflect my graph over the x-axis. All right, so let's make a note. Now, if you think about what that means, I'm going to reflect my graph over the x-axis. That means that every value of y that was originally on my graph is now going to change signs. So if I had a point, say for example, I had this point right here, 10, 1, now that point's going to be here. So, well, what really happened? My y value became negative. This is 10, negative 1. This is 10, 1. This is 10, negative 1. So when I'm reflecting over the x-axis, I'm going to be negating all of my y values. So let's just put that in there. Negate y. Make them all, change the signs. Now the 2 means that I am going to have a vertical stretch of 2. So let's write that. That's a vertical stretch. And what does that mean in terms of my actual coordinates? Well, that means that I'm going to be taking all my y values and stretching them because I'm having a vertical stretch. So I'm going to be multiplying my y values by 2. So that means multiply 2, all right, by my y values. And then lastly, inside the parentheses, I have that x plus 4. That means that I'm going to be moving my function left 4. Okay, so I'm going to go left 4, which means that I'm going to have to subtract 4 from all of my x values. All right, so in terms of x, I'm going to be subtracting 4. So I'm going to have 0.1 minus 4, 1 minus 4, and 10 minus 4. And then I have to do 2 things in terms of my new y values. I have to put a negative in front. I have to negate the y's. And I have to multiply them all by 2. So basically, I'm going to multiply all my y values by negative 2. Right, so I'm going to plot those. Now, before I do that, I do want to write in my vertical asymptote. It's just a good guide for my graph. My whole function, I said x plus 4. My whole function went left 4. So that means that I have a vertical asymptote at x equals negative 4. All right, we'll draw in the coordinates and sketch the graph. All right, and our graph did behave the way we expected. We reflected it over the x-axis, we stretched it, and we moved the whole graph over left 4. All right, so let's try number 6. It says, describe and correct the error in graphing the function log negative x. Now that negative in front of the x means that we're going to reflect over the y-axis. This graph, though, reflected over the x-axis. So this graph went this way instead of going this way. So this function should reflect over the y-axis, not the x-axis. Number 7, describe and correct the error. We have the function log x plus 3. The plus 3 is in the parentheses. Right now, it looks like this whole function went right 3. So you notice right here, we've got this asymptote at x equals 3. We're supposed to be going left 3, not right 3, because inside the parentheses is going to be the opposite. So this function should shift left 3, not right 3. Okay, that's all I have for this video. Thanks for watching. Have a great day.